Today, we are talking about Google DeepMind, a company that's on a mission to do something that sounds, well, almost impossible: build artificial general intelligence. We're not just talking about smarter apps here. We're talking about a technology that could fundamentally change everything about human progress. So, let's get into it.
Right from the jump, back in 2010, this was the goal. I mean, think about that for a second. Not just to build a clever product, but to literally solve the puzzle of intelligence itself, and then use that key to unlock every other problem. It's the kind of thing you'd expect to read in a sci-fi novel, not a corporate mission statement, and it has driven everything they've done since.
So, how in the world does a company go from this to this? In 2013, they were teaching an AI to get really good at old Atari games. Fast forward to 2026, and they're a core partner in a U.S. national strategy to revolutionize science itself. That incredible jump, that escalation, that's the story we're going to unpack.
So here's our roadmap. We'll start with their crazy ambitious origin story, see how they became the core AI team inside Google, look at their mind-blowing work in science, explore how they're literally creating a new way to discover things, and finally, tackle the big one. How do you even begin to manage the risks of something this powerful?
All right, first up, the mission to solve intelligence. And forget the typical Silicon Valley garage story. This one starts in the world of neuroscience, with this big idea to build an AI that actually learns a bit like a human brain.
So their secret sauce early on was something called deep reinforcement learning. It sounds complicated, but the idea is actually pretty simple. Seriously, think about how you train a puppy. You've got a brain, that's the deep neural network, and you give it treats or rewards when it does the right thing. The AI just plays and plays, learning from trial and error, getting rewarded for a higher score. No one had to program in the rules for Pac-Man, it just figured it out.
And yeah, that kind of breakthrough gets you noticed. So in 2014, Google swooped in. And you've got to understand, they weren't buying a product. DeepMind didn't have any. They were buying the team. They were buying the mission. They saw this small group as probably the most concentrated hub of AI talent on the planet, and they wanted it.
Okay, so let's move on. For a long time, DeepMind kind of did its own thing inside of Google, with a ton of freedom. But then the entire AI world exploded, and by 2023, it was time for a huge change. See, inside Google, you basically had two heavyweight AI labs. In one corner, you had DeepMind in London, super academic, focused on those big research moonshots like AlphaGo. In the other corner, you had Google Brain in California, the powerhouse that built the stuff that actually runs Google. You know, search, ads, they invented the transformer for crying out loud. They were basically rivals with totally different styles.
Well, that rivalry came to a screeching halt in 2023. Why? One big reason was ChatGPT. Suddenly, the pressure was on. The whole idea behind the merger was to get past any internal panic, combine these two incredible teams, and create one unified engine room to build their next-gen AI, Gemini, and put it in absolutely everything.
Now, with this new unified super lab, they didn't just point their brainpower at consumer products, they aimed it at some of the absolute biggest scientific questions out there, starting with the very code of life itself.
And the numbers here are just staggering. Just take AlphaFold. It predicted the 3D shape of over 200 million proteins. That's basically every known protein in existence. And they just gave it away. It's now a fundamental tool used by millions of biologists and researchers every day.
But why stop there? Next came AlphaMissense, which looked at 71 million tiny little typos in our genetic code to help figure out which ones are harmless and which ones could lead to diseases like cancer. It's like having an AI that can proofread our DNA for devastating errors, a total game changer for medicine.
And this isn't just sitting in a lab somewhere. A spin-out company, Isomorphic Labs, raised more than $500 million to do one thing: take these digital predictions and turn them into actual drugs. We are on the verge of human trials for medicines that were first dreamed up by an AI.
So they went from the building blocks of life and zoomed all the way out to the entire planet. With Alpha Earth, they're building a digital twin of our world. It pulls together all the satellite and climate data into one model. Think of it like a living, breathing, searchable map of the planet's health. So precise, it can track the trees on a single city block or watch a glacier melt in real time.
Okay, so this brings us to a really fundamental shift, and this is where things get a little weird. AI is no longer just a tool that helps us analyze things. It's becoming a collaborator, a partner that can actually make discoveries all on its own.
So meet Aletheia. It's an AI designed to be an autonomous researcher. The way it works is brilliant. One part of the AI generates a possible solution to a problem, another part acts as a skeptic, a verifier, and checks the work. Then a third part revises the solution based on that feedback. It's basically an AI scientist that argues with itself at lightning speed to get to a better answer.
And the results? They're frankly stunning. Aletheia is already performing at PhD level on super tough math problems. But here's the kicker. It has already solved 4 math problems that had stumped human mathematicians for years. Let me just say that again. The AI isn't just solving problems we give it. It's solving problems we couldn't solve ourselves.
Now, when you build a tool that can do that, governments start paying very close attention. And they have. DeepMind is now a lead partner in the Genesis mission, a massive U.S. government project with the stated goal of using AI to kickstart a new golden age of science and technology.
And the ambition here is just off the charts. We're talking about using AI to speed up our path to clean fusion energy, to design the next generation of computer chips, to completely automate the process of drug discovery, and to make our power grid radically more efficient. This is AI becoming national infrastructure, as fundamental as roads and electricity.
Okay, so the power is undeniable. The potential is immense. But this all leads to the big, looming question. With this much power, how on earth do you make sure it stays safe and actually benefits humanity?
Well, to even begin to get a handle on it, DeepMind created a sort of capability scale for AGI. Think of it like a Richter scale for AI. It goes from level 1, which is kind of like an unskilled person, all the way up to level 5, which is superhuman, meaning it's better than any human at a given task. Right now, the top models are starting to hit level 3, expert, in some really specific areas. And to manage the risks as these systems climb that ladder, they've built a 2-tiered safety system. You have one group that focuses on the here and now problems, things like bias and making sure the AI follows ethical rules. But then you have a separate AGI safety council, and their job is to worry about the extreme sci-fi stuff, like what if a superintelligent AI tries to deceive us or bypass its safety controls? This isn't just about ethics, it's about maintaining control.
So we've watched this incredible journey, from an AI that could beat you at Space Invaders to an AI that's reshaping science and national strategy. The direction is clear, but it leaves us with one final, massive question. As artificial intelligence stops being a simple tool that we use and becomes more of a partner that we collaborate with, who gets to decide what we discover next? Who sets the agenda for the future?